Hi everybody. I'm just going to run through some percent yield problems with you. These problems are on page 11 and 12 of the guided note packet. Percent yield is really simple. You guys do percent yield every time I hand you your test back. You immediately look to see the number of points you got out of the number of points that you could have gotten. Let's say you got 8 points out of 10 points. 10 points would have been the amount that you could possibly get, and the number that you actually got was 8 points. So really, I just wrote this here next to the formula for percent yield. The actual is always the amount that you actually got, and the theoretical is the amount that you expected to get. I hand you back a test and you got 8 out of 10. Well, you might have expected to get 10 out of 10, but you only got 8 out of 10. So percent yield is really just kind of telling you how well you did, let's say, in an experiment. Let's say that you wanted to make a certain amount of chemical. The stoichiometry is telling you that you should make, let's say, 10 grams of water. Let's say you were making water, and stoichiometry was telling you that you should make 10 grams of water, but then you made the water and you only got like 9.8 grams of water and not 10. So what happened during the experiment that you lost some of the expected amount that you thought you should have gotten? Anyway, we're going to run through a couple problems now, and we'll first do the stoichiometry, and then we're going to calculate the percent yield. All right, let's start with problem number 1. We are given 6.92 grams of sodium and an excess amount of oxygen. So the reaction is going to stop when we run out of sodium. Since oxygen is the excess, 6.92 grams of sodium is the limiting reactant. All right, first off, I got to solve for moles. Okay, so we have 0.3 moles of sodium. All right, I set up my BCA table. Now, I did not necessarily have to use a BCA table for this, but since I've already shown you how to use BCA tables for limiting reactant problems, I just thought, what the heck, let's just go with the BCA table. It doesn't matter, really. So what the stoichiometry is showing me is that I'm going to make 0.15 moles of sodium oxide, okay? Actually, this is sodium peroxide. Never mind. So let's see how many grams of sodium peroxide would come out of 0.15 moles. Okay, so we would make 11.7 grams of sodium peroxide because the molar mass for sodium peroxide is 78 grams. Okay, 11.7 grams of sodium peroxide. This is the expected amount. This is the theoretical amount. I'm just going to write that down. This is the theoretical amount. Okay? I mean, this is how much we would make if everything went perfectly. No mistakes were made. All measurements were perfect. Everything was perfect in our experiment, and we made as much sodium peroxide as we could possibly make. That would be 11.7 grams. Well, actually, in the problem, it says that we really only made 5.34 grams of sodium peroxide. So what is the percent yield? It's, we only made 5.34 grams out of the possible 11.7 grams. So I'm going to write this out. All right, so 5.34 divided by our theoretical amount, 11.7, that's only 45.6% yield. That's not so great. I mean, there were some mistakes that were made during this experiment, apparently, and that's what happened. But this is the percent yield. All right, let's try some other examples. Okay, so let's try this next one. So here we've got, like, what is it called? Tetraantimony hexoxide. Who cares? Okay, I'm gonna just start with calculating the number of moles of this compound that we're starting with. We're being given an excess of carbon, so we don't have to worry about that. Our reaction is going to be limited by the amount of this antimony oxide that we're given. Okay, so let's just calculate how many moles of antimony oxide we're given. Here we go. All right, this antimony oxide has a pretty high molar mass. It's 583.2 grams per mole. All right, let's see how many moles we have. All right, so we have 0.0482 moles of this antimony oxide. Okay, I'm going to set up a BCA table again to see how much product we're going to make. And the product that we care about here is just antimony. So we're going to get antimony out of this. Okay, so of course we're going to use up all of the antimony oxide because we have excess carbon. And I did not have to do any calculating for the carbon at all, but I threw it in here just so that you could see, if you were curious, how much carbon would we actually make? I'm sorry, how much carbon would we actually use? Sorry. We would use this much carbon, and in the end we would take whatever excess that was and take 0.289 out of it. This was totally unnecessary. I just did it because stoichiometry is fun. And I'm kind of a nerd, so I admit it. All right, so here we go. We're using up all of the antimony. We're going to end up with 0 antimony oxide. Sorry, antimony oxide, not antimony. So how much antimony can we make? Well, we're starting with 0, of course. And carbon monoxide, they're not asking for it, but I'm just filling it in anyway. The amount of antimony that we're going to make is going to be 4 times greater than the amount of antimony oxide that was used. So I'm just going to take 0.0482 times 4. Okay, so 4 times 0.0482 is 0.193. So we're going to, I should have wrote 0.193. I wrote 0.194. Let's fix that. Sorry about that. Somebody's going to be confused by, why did you do that? It just happened. Anyway, all right, so we're making 0.193 moles of antimony. Let's see how many grams that is. Okay, so we're going to make 23.48 grams of antimony. How does that compare to the amount that we actually made? Okay, looks like we actually made 17.3 grams. So that turns out to be 73.7% yield. Okay. All right, so that's 2 problems right there. We could try another one. I think I'll close out the video now because maybe this is just under 10 minutes. And I'll make another video where I do more problems like this. But if you're already on board and you feel like you really got this, then we don't really need to go on. But I will make more videos. I will post more right now. But I'm going to close this one out. All right. Hope you guys are understanding this. Please email me if you have questions. All right.